the mutual information, the worked out example. For example, let us take one example of to find out the output probability and the input probabilities and mutual information and all, etc. of this kind of example. So whenever the channel is given with input probability and the transitional probabilities, you can find out output probabilities as well, the individual entropy, either input and output, as we mentioned, that can be calculated mutual information. So finally, what is the mutual information? To find out the mutual information of a given channel. For example, the input probabilities are given like this, and we'll have transitional probabilities also. The example of like to find this is what to find, okay, output probability, average information of input output, giant entropy, and h x comma y, and mutual information I x comma y. So this is the example like this. When given probability, input probability P of xj is P of x0 0.4, P of x1 0.3, P of x2 0.3. Sum of all the probabilities will be 1. So if this is what x0, x1, x2, and we have the transitional probability, the output channel is y0, y1, for example, y2. Okay, so this is where input probabilities are given. So you can find out the average information based on the definition. Probabilities are known. Logarithmic probability into logarithmic base to 1 by probability sum of all you will get. And the transitional probability for every x0 given what is the output y, P of yk at xj, these are all given. For example, I take x0 to y0, let us take this is 0.8, and x0 to y1, this is 0.1, 0.2, this is 1. So from x1 to y0, from x1 to y0, this is 0.7. x1 to y2, it's 0.3, it is also 1. From x2 to y1, for every input, there may be any output. There may be any output. y1, so this is where 0.4, and x2 to y2 is a 0.6. This is also 1. So the transitional probability P of yk at xj is, as we know that for every input, this is the first row, for every input, the different outputs. Okay. So for every input, first row, for every x0 input, the output of y0, y1, y2. So this is where P of y0 at x0, that is where say 0.8 for every input. Again, for every input of x0, 0.2 for y1. Okay. And there is no y2 from x0. y0, x0, y1, x0, y2 at x0. So that is what probability. Second row, for the second input, x1. So x1 probability x1 at y0, that is what 0.7. Okay. X1 at y, from this is a probability y1 at x1, y1 at x1. So y0 at x1 is 0.7, y1 at x1 0, that is 0, nothing. y2 at x1, that is 0.3. This is also 1. So probability of y0 from x2, that is 0, nothing is there, 0. y1 from x2, this is 0.3. y2 from x2, that is 0.6. This is 0.4. This is 0.4. Okay. Again, this is 1. Okay. This is 0.4. So this is the transitional probability. Now we'll get the output probability. Output probability P of yk. P of yk. You will get P of yk. What is P of yk? P of yk equal to sum of all P of xj and P of yk at xj. Okay. For all j, fixed for yk. So for all j. So this is what the product in the simple, and also this is nothing but P of yk at xj into P of xj. This is also joint probability. This is also a joint probability. You can find out joint probability also. So this is where we can find out the joint probabilities yk multiplication of in the matrix form P of xj 0.4, 0.3 and 0.3. Okay. And this is the transitional probability 0.8, 0.2, 0, 0.7, 0, 0.3, 0, 0.4, 0.6. Okay. If you get joint probability, sum of all joint probabilities, each one is 1 P of yk for every column. So again, you can multiply and product this multiplication, you can sum it, that you will get P of yk. If you want the joint probability, you can multiply individually. That is where joint probabilities Here multiply P of y0 at x0 into x0, like that. P of yeah, P of y0, that is what that y1 at x0 into x0 x1, like that. X0 P of y0, this is what each one multiply each one 0.4 into 0.8, you will get this 42. Okay, this you will get y0 at x1 into x1, P of y0 at x1 into P of x1. So you multiply this one, you will get 0.7 into 0.3 and 0 into 0.3, P of y0 at x2 into x2, P of x2. Okay, this is what 0. And similarly here, P of y1 at x0 into x0, P of x0. Okay, so this is where 0.2 into 0.4, 0.8. Okay, 0.08. Okay, 0 into 3, 0. 0.4 into 0.3, 0.12. Okay, and similarly 0 into 4, 0.4, 0. 0.3 into 0.3, 0.09, 0.09, 0.6 into 0.3, 0.18. Okay, so P of y0, yk, you can get it. This is what some product. This sum is P of y0. P of y0 is 0.53. P of y1, this is what P of y1 is 0.08, 0.12, 0.2. Okay, 0.2. Sum of all 0.09, 0.18, 0.27, 0.27 P of y2. So output probabilities of P of yk, sum of all, okay, P of xj at yk, okay, for all j. This is for all the inputs of j. So this is what P of y0 0.53, P of y1 0.2, P of y2 0.27. You can check this, sum of all probabilities will be 1. See 0.53, 0.27, okay, 0.8, 0.8 plus 2, that is 1. So we got the probability P of yk. Okay, and the mutual information you want. So that is what the h of x is sigma P of x logarithmic base to 1 by P of xj is there from the input probabilities, okay, for all j. And you can get hy, P of hy. So this is what is over. You can get this from this. Take a logarithmic product is. So like h of y is, you have probability P of yk of all these. You will get h of y sigma for all k P of yk and logarithmic base to 1 by p of yk. So like this. So that is nothing but, and you have joint probabilities of p of xj and yk, and you will get h of x comma y also from this joint probabilities. Okay, that is where the sigma of p of xj yk logarithmic base to 1 by p of xj yk for all j, for all k. There are 9 elements. You can multiply this product, you will get the giant entropy. So if you get this giant entropy, that entropy and h of y and h of x at y, giant entropy, the mutual information, you will get using one of the property h of x plus h of y minus h of x at y. So this is where you can take a sigma for p of xj and logarithmic 1 by p of xj for all j. So this is nothing but you have 0.4 probability multiplied with logarithmic base to 1 by 0.4 plus 0.3 multiplied with logarithmic base to 1 by 0.3 plus same way 0.3 logarithmic base to 1 by 0.3. So you will get this, you sum it. So logarithmic base 2, we have to use that. Otherwise, if you take logarithmic base 10, you need to multiply with 3.32. As per the logarithmic principle, we will have the scaling multiplication factor 3.32 logarithmic base 10, which is equal to logarithmic base 2, you will get back directly. Okay. So similarly, h of y sigma p of yk logarithmic base 2 p of yk for all k, as you have the output probability point y0 0.3 multiplied logarithmic base to 1 by 0.3 plus 0.2 logarithmic base to 1 by 0.2 plus 0.27 logarithmic base to 1 by 0.27. So you will get h of y. Okay. Now h of xy, h of x comma y, you have to find all the probabilities. Giant probabilities are there already. Sum of all j and k, p of xj, yk logarithmic base to 1 by p of xj, yk. Okay. And that you can take it as all 9 elements are there. These are all the 9 elements of giant probability. So this is what giant probabilities which are calculated. Okay. So these are all multiplied 0.32 logarithmic base to 1 by 0.32, etc. Like 0.21 logarithmic base to 1 by 0.21. There are 9 terms 0 and 0.08 logarithmic base to 1 by 0.08 plus, okay, 0 plus 0.12 logarithmic base to 5.12, okay, plus 0 plus 0.09 logarithmic base to 1 by 0.09 plus 0.18 logarithmic base to 1 by 0.18. There are 9 terms, sum of all you will get. So mutual information, you will get it from this equation. You can get this value, you can get this value, you can get this value, you will get this. So that is how, if logarithmic base 2 is unable to calculate, you can use logarithmic base 10, you just multiply with 3.32. So that is how the mutual information, and we got P of yk output probability, entropy, input entropy, output entropy, and joint entropy, and mutual information I. These are all calculated. The problem is like to find any one of the thing. So if at all mutual information is asked for, and you require all these things anyway, you will calculate. If something is defined like to understand, to calculate, you can calculate the same. Similarly, you can also for the given input probability and transitional probabilities here, and that something maybe you can also ask for see here mutual information I x comma y equal to h of x minus h of x at y. This is also there. The mutual information y at x is h of y minus h of y at x. This is also there. So already h of x is there, h of y is there. Here h of y at x, that probability, transitional probability y at x probability is there. Transitional probability, you will get the conditional probability, conditional entropy here. So h of y is there, conditional entropy you will get. So this minus this, you will get the mutual information, which is same, x comma y is same as y comma x. Okay. So as we have taken that transitional probability h of y at x, the definition is already given. In the same way, the probabilities, that conditional probability, you will get. This is what sigma double summation for j for all k. Okay. So this is where joint the mutual information of a discrete memoryless channel. Once you know, you have given the input probabilities, transitional probabilities, the respective probabilities, and the required output probabilities, and accordingly from there the average information and mutual information you will estimate, you can calculate. That is how about the mutual information today's class. Okay. Thank you. Thank you very much.